Ciao friends, and welcome to a new video from SQL BI. In this video, I want to answer a question that I quite often read on Twitter or when professionals discuss the topic. And the question is, if you have a date column that needs to be stored in the sale table, is it better to store it as a datetime or as an integer? Because you can store a date as a datetime, you have the datetime data type, and you can also store it as an integer. The general format is 4 digits for the year, 2 digits for the month, and 2 digits for the date. Both structures, both ways of storing dates are totally fine. But which one is better and why? As always, better depends on the definition of better. Better might be smaller, better might be faster, better might be easier to use. And the common sense dictates that integers should be better, because generally speaking, integers are always the best way to store data and to compute values on top of data. So if you are used to general databases, then you will probably choose an integer just because it looks better. As it turns out, Tabular is quite different. Because of the way Tabular compresses the data, there are actually no relevant differences in storage and in speed when it comes to using an integer or a datetime. There is actually a small difference in the usability of the column. Using a column with a datetime data type is actually easier than using an integer. That is why, in my personal opinion, using a datetime is better. But this is not about opinions about data. The good thing about computers and IT is that whenever we have a question, we can answer to it by taking some measures. So what we are going to do now, we are looking at a data model that contains around 2 billion rows, where I created a version of the data model that contains the date as a datetime, and another version that contains the same values, but this time stored as an integer. And we perform some measures in order to understand which one is better and why. Let's get started. As I said, I created two different models. The first one is using date key, an integer. The second one is using date, so a datetime. If we look at DAX Studio, this is the model containing date key, and you see that we have the order date key and the delivery date key. These are two columns that contain integer values. Let's quickly look at the content of these columns. If we do evaluate all sales order date key, a bit larger, you see that the content of order date key is an integer in the form year, and then 2 digits for the month and 2 digits for the date. Then I created the very same model, which is Contoso 1G, but this time is with date. Now sales contains the order date and the delivery date, and if I evaluate the content, it will not be order date key, it will be order date. And the content is just a date. So the two data models have two different structures. 2 billion rows in the sales table. One is storing a date, the other one is storing an integer. Which one is better? As it always happens, better depends on what you mean by better. But specifically in Tabular, better is quite always smaller. If you have a smaller column, that will be faster to scan and to compute. So the first thing that we need to understand is which of the two formats provides a better compression, a better storage. And we need to talk a bit, just a bit about theory before. Whenever you store a column in Power BI or in Tabular, that column will be compressed. There are different compression techniques, but specifically for columns that are used in a relationship, the engine always uses hash encoding. Hash encoding transforms any column into an integer because it creates a dictionary with all the values of the column and transforms the column into integers that points into the dictionary. That is going to happen for both the integer and the date column. That is why, from a theoretical point of view, based on the knowledge we have about Tabular, there should be no difference at all between using a date or using a date time. But we can check that. So let's look at DAX Studio. We have this connection, which is with Contoso data, and we look at the matrix. Okay, so this is our sales table, around 2 billion rows, and we have delivery date and order date. Let's look at the numbers. We have 2.7 gigabytes for delivery date, and around 2.5 gigabytes is the space used by order date. That for a column containing dates. What about if we do the same, but this time with date key? Let me just double check that was date, and this is date key. Let's look at the matrix. Sales, and now we have delivery date key and order date key. And look at the size, 2.9 gigabytes for delivery date key and 2.6 gigabytes for order date key. So we have 2.7, 2.5 for the date, and 2.9, 2.6 for the date key. Therefore, what we can conclude is that the integer is slightly larger, but it's really slightly larger. That difference in terms of size might depend on a lot of causes. It might be because of the sort order. It might be because some time boxing that happened during processing. The important detail here is not that they are different. They are different, but really lightly. The difference in terms of size between using a date or an integer is irrelevant. And because the difference in terms of size of the column is irrelevant, I would not expect any difference in terms of performance, because it will take the same time to scan a column that contains 2.6 gigabytes or 2.5 gigabytes. They are nearly the same size. Again, we can measure that, so let's do it. We run a simple query that, instead of evaluating order date, does evaluate summarize columns. We group by data. We always group by the dimension because we want to use the relationship. And we call amount, which is, I don't have the measure, sum x over sales of sales quantity times sales net price. I need a bit more space. Okay, sales net price. Okay, let's measure the time that is needed to run this query. I'm grouping by date. I'm computing quantity times net price. So I'm basically using the relationship between the two columns in order to group by date. Server timings is active. Let me run it. And here we are. The entire query was executed in 337 milliseconds. 17,000 is the storage engine CPU. Always remember, this is the number to look if you are worried about performance, because this is the amount of CPU used. This is the actual execution time, but it's taking into account parallelism. So this is with I lost it. This is with the date. Let's run the same query now with the date key. The query is the same because I'm grouping by date data, therefore I'm just using the relationship. We need to activate server timings here. It was 300 milliseconds on using the date, and if we run it using the date key, it's 345 milliseconds. So again, the difference is there, but it's so small that it's totally irrelevant. If I run the same query again and again, I would obtain probably very similar results. So that is useful to draw the first conclusion. Either you use a date or you use an integer, performance is nearly the same. Therefore, it does not really matter which of the two formats you choose. If your data model already contains an integer, you can use that. If your data model contains a date, just use that. There is no point in using ETL code to transform one data type into another for the purpose of performance. But actually, as I said in the introduction, there is a small difference in terms of usability of the columns. Because if you have dates in your sales table and you need to perform math on these columns, then you already have the value stored in the sales table. Whereas if you have an integer, that is an integer that points to the date, and you need to do math on dates, you will always need to traverse a relationship to grab the value of the date in order to perform the math. And that might have a cost that might also depend on the complexity of the calculation that you want to do. Let me show you that with an example. I'm going to write a query that computes the average delivery time in dates. That is the difference between the delivery date and the order date. The difference between the two dates provides the number of days between the two dates. And averaging them, I have the average number of days to deliver my orders. Let's do that. Let's start with that is delivery date, order date, and this is date key. Okay, let's start with the date. I can group, let's do that by year. I can group by year and I can group by month number. And then I want the average delivery days, which is an average X over sales of sales delivery date minus sales order date. And that's it. I don't need anything more complex than this because delivery date is already a date, sales order date is a date, average X will compute the average of all that. I can just convert that into, well, that doesn't matter. I'm not interested in the result. I already have server timings enabled, so we can run it. This needs to run a query, a storage engine query that computes the difference between delivery date and order date, and it runs in 732 milliseconds. I'm not interested in the result, just in the time that is needed in order to compute the value. If I try to do the same using the other model, let me copy the code here, then I'm a bit in trouble because I don't have the delivery date and I don't have the order date. I have in the model the order date key and the delivery date key, two integers, whereas what I want are the dates. Now, for the order date, that is not that hard. I can use related sales order date, and I can use the relationship that exists between order date and date. But performance-wise, I will need to use this relationship. That is not utterly expensive because date is small, but I need to do that. The problem is with sales delivery date, because while it is true that I also have a relationship between delivery date and date, that relationship is inactive. And activating a relationship in a row context, as I'm doing here, proves to be quite challenging. Now, if you really want to discover why it is challenging, I created an article and a video that talks about how to activate an inactive relationship in a row context or in a calculated column. That is one of the most complex articles and videos that I have ever created. So for the brave among you, just go there and take a look. If you are not interested in all the details, just keep in mind that you cannot easily activate a relationship while scanning a table. That is why we will need to use lookup value. Instead of activating the inactive relationship, I store in a variable the delivery date, and I use lookup value. So I search in date for the value of date, where the date key is equal to, let me reduce the font a bit, okay, is equal to sales delivery date key. So now I have in delivery date, in the variable delivery date, my delivery date, and I can use it here. Okay, that's it. But you see, the code is more complex than the previous one. We need to traverse a relationship here, and we need to use lookup value here. So I would expect this code to be slower than the previous one. Now, it was running in 732 milliseconds when executed in the model with the date. And what's happening here? I'm no longer connected with... let me reconnect to the model and enable server timings. Okay. And double check that I'm using actually the right model. Contoso date key. That is the model that I want to use. Okay, it doesn't work because that is not sales order date. That needs to be date. Okay. Let's look at the server timings. You can easily tell it's gonna be slower just by the time that it takes, but you can also measure it. It's 3 seconds against 700 milliseconds. So it's around 4-5 times slower. Not only it is slower, but if you look here, we also have our problem, that is a callback date ID. The presence of this callback date ID means that Formula Engine is heavily involved in the calculation. Therefore, performance is going to be worse and the usage of the cache will not be as good. So you see that there is a difference in terms of usability of the columns. If I store a date, then I have the column ready to be used in my sales table. If, on the other hand, I store the integer, then I always need to traverse relationships or write more complex code if I cannot easily traverse a relationship. That slows down several calculations. Actually, before leaving the topic, I want to show you that you can actually optimize the model that contains the integer, avoiding the callback date ID and obtaining similar performance. But you need to do a small change to the data model. Let me show you that. The problem I have here is the usage of this lookup value. Now, this lookup value is required because I cannot easily activate the relationship between delivery date key and the date key. The relationship is there, but I cannot use it because I already inside an iteration that activated the default relationship. So what I can do in this scenario is create a table that only contains the dates. It will contain a date key and the date, and I create the table, build a relationship with this table so that I will have two different relationships. One relationship will be with date, the other relationship will be with delivery date. Two different relationships that can be active at the same time. That is why I will be able to use related also to grab the delivery date. And at that point, performance will be slightly better. So what I need to do is create a table containing all the combinations of date key and date, then build a relationship between delivery date key and this newly created table, and finally use related in the expression. So first thing, we need to use a tabular editor that I already have open here. to create the table. This is Tabular editor connected with the date key model. So we create a new calculated table and we call it delivery date. And the content is just all no blank row, date, date, and date, date key. Okay, so all the combinations of date and date key. Let me save it. I can look at the content. You see it's empty. I need to refresh the model. I can do automatic because I only created the table. And I should be able now to preview the data. There's nothing there. Yes, because that needs to be date, date, and date, date key. Let me save that again, refresh the model, automatic, then I can go on delivery date, and now you see I have all the combination of date and date key. And at this point I can create my relationship. I create a new relationship between sales delivery date key and not date but delivery date key. It goes many to one. It's enable no by die. Save it again, refresh automatic because I only need to build the relationship. And now that the relationship is in place, I can instead of using lookup value, I can just use related delivery date, because now this relationship is using the newly created relationship. And actually I can get rid of the variable entirely and use just related twice. Once to retrieve the delivery date, once to retrieve the order date. And if I run the query now, you see that it takes 821 milliseconds first, and most relevant, it is not longer using any callback date ID. So now performance are close to the ones with the data, and I got rid of the callback date ID. But I had to slightly change the data model, introducing a table only for the purpose of performance. So, what are the conclusions? They are quite simple indeed. If you have a date stored as an integer in your original table, you can keep it as it is. If you have a date stored as a datetime in your original table, again, you can keep it as it is. There are no particular reasons to convert a date into an integer or an integer into a date from the performance point of view. There is a slight difference in terms of usability. Storing dates proves to be a bit better because you already have the columns available in your table, and if you need to perform math, they are already there. If you do not need this kind of math, but you only need to slice and dice, then there are no differences at all. And in the case where you have integers and you need to perform math, then slightly changing the model might provide you better performance by creating a simple calculated table that lets you use a relationship twice inside your DAX queries. I hope you enjoy watching the video and, as usual, enjoy DAX.